How does current flow in a circuit with a capacitor? Suppose a circuit with a switch contains a capacitor. At time t=0, the switch is closed. Picture-wise, we have our source, and we have our capacitor. So the capacitor starts off initially uncharged, but at t=0, there is current flow that's going to occur. There are many ways to interpret current flow. With the capacitor, of course. But I will use the potential incline model to explain current flow, since it's more physical. No charge can pass through the dielectric of the capacitor the physical current therefore must follow some other mechanism. I will do this in steps So let's do it. So our first step is that you have to realize is that there are already plenty of charges, that is weakly bound charges, in the wires. The moment the switch is closed, there is current flow everywhere. In the circuit. So I'm going to come up here and get this circuit and bring it down with me and modify it. So if I'm looking at my circuit, then the switch is now closed. And what happens is that there is current flow everywhere. So that means I have charges everywhere in the wires. And in this case, since we're talking about positive current flow, I have little positive charges that are there. So the moment it switches over, there is no charge on the capacitor, so its voltage is 0. So picture-wise, what does this actually mean in the potential model? So in the potential model, I have an incline with the capacitor in there. And once again, I have my charges. My charges are located everywhere in the circuit. Okay, there. So now the switch is closed. So what happens now? So if you're looking at this picture, you're seeing here that now charges flow down towards the upper plate, while charges flow down away from the lower plate. Since the capacitors conducting plates start off neutral, we could see here that the upper plate gains extra positive charges. And that means it gets more positive. Let me move this over a bit. On the other hand, when I'm looking at the lower plate, we could say here that the lower plate loses loses, let me be careful, loses charges and as it loses charges, it gets more negative. So if I take my incline now, I am seeing something like this. So if I bring this right here, I'm seeing that I am getting current flow And as I get current flow, what happens? I build up positive charges here. And on the other hand, I have less positive charges, so I get negative. So this here is the current in the branch, which means that that's the current of the capacitor. So now, just to put in words what I just stated here, 3, as more and more charge builds up on the plates, the capacitor's potential increases. However, the potential difference between the power supply and capacitor is now decreasing. In other words, this tells me here is that the potential difference between the source and the capacitor decreases. This causes the rate of current flow to also decrease until the potential difference between the two reaches 0. In other words, the voltage of the source minus the capacitance is 0. Only then is the capacitor said to be fully charged.